So today is October 17th. It's a Wednesday, and what we did is we put two things into our notebooks today. We put a Learning Target 2 and a Learning Target 3 on page 50, and we did a graphic organizer, and what we looked at was, do we know how to name ions and how to determine oxidation numbers? Do we know what oxidation numbers mean, and what happens to electrons during ionic bonding? So what we did is we talked about this little graph here, and this is a periodic table. It's kind of shortened up, and what I did for you here is I put the oxidation numbers at the top of each family group. So remember, you can see I put in green, I don't know if you can tell that's green, but I hand wrote the number of valence electrons each one of these has. So family group 1 has valence electron 1, 2 for family group 2. When you come over here for 13, you have 3 valence, 4 valence, 5, 6, 7, 8. So those are the valence electrons. This here is called your oxidation number. So you notice your valence electrons follow the pattern of 1, 2, 3, 4, 5, 6, 7, 8. Your oxidation numbers follow the pattern of +1, +2, +3, plus or minus 4, -3, -2, -1, and 0. So your oxidation number, what it is telling you, sometimes it's called an ionization number. So it's telling you what's going to happen. We've talked about positive and negative ions, and that's exactly what this is saying that this is. So everything in family group 1 will form positive ions. They'll form positive 1 ions, meaning they have 1 valence electron, and they're going to give that electron away. Because remember, giving electrons away is how something becomes a positive ion. So if I give away 1 electron, then this group can become stable. Same thing, group 2, they have 2 valence electrons, and they're going to give away 2 electrons, making an ion form of a positive 2. So once magnesium bonds, it becomes a magnesium with a positive 2 charge. Calcium becomes a calcium with a positive 2 charge. Each thing in this family group is giving away those 2 valence electrons. They're going to give them to a nonmetal, and we're going to see that in a minute. So everything in this group, it gives away 3 electrons. They have 3 valence electrons to give, and they're going to give them away. In this group here, family group 14, most likely, most of the time, these things form covalent bonds, but that's why we put a plus or a minus. Sometimes they give, sometimes they take. There's some situations where that happens, but what happens is, most of the time, these are covalent bonds, and you don't really have to worry about a charge at all anyway for that family group. This group here, they have 5 valence electrons, and they are going to gain 3 electrons to make a total of 8 valence electrons that they have. So if you think about this family group here has 3 to give. This family group here wants to get 3. They have a -3 charge. So a lot of times if you're looking at, not always, but this group and this group make a good bond together because they're giving away 3, and the elements in this group are taking on 3. So those guys will bond together. This group here, family group 16, the oxygen family, they have 6 valence electrons, and so they're looking to get 2 more. So they're going to gain 2 more to try to become stable. If this group here, family group 17, the fluorine group, has 7 valence electrons, and they need 1 to become stable. And then this one here is your noble gases. They have 8 valence electrons. Remember the octet rule that says if you have 8 valence electrons, you're stable, and that is true. These guys are not going to give away or take any electrons. There's no electron transfer. The reason is because this group here is not going to bond. So that's to know how to find your oxidation numbers. You look at their family. So how do you determine the oxidation number? Well, you look at the family group it's in, and you look at the oxidation number for the family. On your periodic table that we coded in class, which is on page 41 of your notebook, I'm going to flip over there right now. You will see that I coded that for you on each one. So this oxidation number for family group 1 is a +1. Oxidation number for family group 2 is +2. You notice that I put, there's your valence, and so all the way across, already on your copy, oxidation number +3, positive -4, -3, -2, -1, and 0. So I've already put your oxidation numbers on your copy that's on, again, in your notebook on page 4041. So we've got that coded, and we've got the oxidation number. So I'm going to flip back to today's stuff. And this we read together in class, so you can read this silently if you want to. And we just highlighted the important information. And then we went through and we took a minute to fill out the bottom. This is a summary, and all this information can be found in your bulleted list. Then, so you may want to pause and make sure you get those correct. On the back side of this is a graphic organizer about ionic and covalent. So learning target 3, do you know the difference in covalent and ionic bonds? So the very first thing that you do, if you have a formula, chemical formula, you look at the elements in the formula. If your elements are a metal and a nonmetal, then it's ionic. If there are two nonmetals, then it's covalent. So you can see that you have a decision to make. You look at the formula. If it's a metal and a nonmetal, ionic. If it's two nonmetals, covalent. And then we just reviewed what that meant. Ionic means the metal gives the electrons to the nonmetal. The metal becomes the positive ion. Nonmetal becomes negative. And covalent, remember, co means to share. Valent means valence electrons. So electrons are shared between the two nonmetals, and neither one becomes charged. I also, at the bottom here, just went ahead and typed some of the properties of ionic and covalent, and we'll do a little bit more with those to identify in a little bit. But those are there for you in your notes. So that is on page, I put that on page 50 of my notebook. And then over here, these are the answers. We did learning target practice, learning target 2 and learning target 3 practice. So what we did is we started off with the ionic notation. And so this one I didn't do a very good job. It really should be written as Na with a positive 1 charge, like that, kind of as an exponent. And then bromine has a negative 1 charge. Magnesium has a positive 2 charge. All we did here was we went to the periodic table, we looked at where those families were, and we put the oxidation number that goes with the family. We did that all the way down. So I'm going to put this up here. You can pause it and scroll through it as you need to make sure you have those answers. Now, the middle column, we had to do the ion names. If it has a positive ion, it does not change its name at all. It just becomes an ion, and you don't even say the ion word, so it really doesn't have a name. So we just left those blank. I wrote the first one in there. It said sodium ion, blah, blah, blah. Doesn't matter. If it's a negative ion, it becomes a IDE ending. So bromine becomes a bromide. Chlorine becomes chloride. Oxygen becomes oxide. Phosphorus becomes phosphide. Iodine becomes iodide. Nitrogen becomes nitride. Sulfur becomes sulfide. Fluorine becomes fluoride. Selenium becomes selenide. Arsenic becomes arsenide. So those are the ion names. Everything else stays the same. One thing that you will notice is that, like neon here, neon is a noble gas. Neon will not have an oxidation number. It's an oxidation number 0. You could put a 0 there if you wanted to. You don't have to in the ionic notation. You just leave it off. So will it gain or lose? This one will not do either because it's going to be doing nothing. But when I go back up here and I look across the board here, this is telling me a lot of information. So sodium has a positive 1 charge. It doesn't have a sodium name. It doesn't change to an IDE name because it's just a sodium ion. And it's going to lose or gain. So we looked at gain or lose an electron. This one's going to lose an electron, and how many? It's going to lose 1. How do we know that? Because it's positive and there's a 1. So it's losing 1. Bromine is a negative 1. So negative means it's gaining. How many? 1. Negative 1, gaining 1. Positive 2 for magnesium. What does that mean? Losing how many? 2. Positive 2, losing 2. So on and so forth down the line. So that's what all that information means. So there's that. And I will scoot up so you can see the bottom as well. So you may need to pause that in a couple sections, rewind the video, or scoot it back a little bit so you can see everything. Then on the back side here, we looked at target practice 3. 2 types of elements make a bond, metals and nonmetals. Ionic bond, and then covalent are 2 nonmetals. And then what we did on this page is all we had to do is the first element a metal, yes or no. iron oxide. Iron and oxygen are bonded together. Iron is a metal, so that is a yes. And then if it's ionic or covalent, it's ionic, because if it's yes, it's ionic. Hydrogen chloride. Hydrogen is not a metal, so that's a no. That's a covalent. Anytime you have a no, it's going to be covalent. Anytime it's yes, it's going to be ionic. So how do I know that? Well, if I go back to my graphic organizer here, I look at the elements in the formula. If it's a metal and a nonmetal, ionic. If it's two nonmetals, it's covalent. So I have to look and see, is that a metal or not? Some of these may be easier to see than others. A lot of people want to say, like calcium. Calcium carbonate. They say calcium is not a metal, but calcium is a metal. We don't think about that because you think about calcium being in milk. But if you look at your periodic table on page 41, if I can turn it over there, I'm not going to take a job as a movie producer, director. If I look here, calcium is on this side. And remember we coded this of metals, nonmetals, and metalloids? And we left all the metals white because there's just so many of them, so we just decided not to highlight. But calcium's right here. And calcium actually is a metal, which is kind of interesting. I've got a book with some pictures, or you can look up calcium as a metal and see it. So that is what we did today in class, and that's just a little tutorial. If you missed it, if you still have questions, see me. Tutoring is on Wednesdays. I just got finished with tutoring today, so you're welcome to stay 3:15 to 4:15 every Wednesday because I'll be here. See you tomorrow.